Nowadays, we live in a world where air pollution is a reality. There are pollutions which are contributing to environmental risks, such as smoke formation, damaged foliage, acid rain, and greenhouse effect. Sonora is identified by these devices that can collect information of the quality of gases that are contributing to air pollution. These sonars have been designed and intended to collect data on ozone, nitrous dioxide, carbon dioxide, temperature, and humidity. Sensors have been sought for gases that have a great impact on pollution, and thus obtain relevant information. These devices incorporate a Wi-Fi module for connection and a GPS system to track where they are located. They can also connect to the GSM network through a SIM, in case you don't have a good Wi-Fi connection, or through an Ethernet port. A slot for microSD and USB port have also been added. All data received can be received and then sent thanks to the STM32L053 microcontroller, which is an ultra-low power microcontroller with a high-performance ARM Cortex-M0 Plus 32-bit RISC core operating at 32 MHz frequency, a memory protection unit, and high-speed embedded memories. To power this device, a solar panel will be used to supply power to a rechargeable battery in the device. The enclosure or box will be 3D printed with recycled plastic to contribute to the environmental footprint left by this material.
The data that the sonar sends to the API in Python are the ones in here. The miner ID corresponds to the country code of the miner and a number. The wallet ID is a unique code that allows us to identify which miner we have to pay. Later, we have all these values which the sonar pick up. At the time of sending the data, we create a single hash for each JSON the sonar sends. This is the main function of the API. To create the hash, we take the miner ID, wallet ID, and the date and time the data is sent. Once we finish to process the data, the API sends a string to Project Air. In Project Air, we have configured our pipeline so that when they are receiving the data, they be saved in the database. To send the data to the Ethereum network, we use this URL which returns the data in a JSON format. This data has been stored in our database using Project Air. However, they are string values, so the API converts the string to a JSON format. If we go to a smart contract developed in Node.js, I will run the application right now, so we can see that in this part we extract information from the API to be sent to the Ethereum network. And we need to wait a moment. We can see that the data has been sent correctly to the Ethereum network.